Time to get started on recapping this 822203. I'm going to get these nuts off the input jacks. I'm using this because it's easier to grab than to grab the plastic with my fingers. I would never use the actual ratchet part of the tool, because if you tighten the plastic nose nuts up too much, there goes the nut, the nosing on the jack itself will just crack, or the plastic nut will crack. But it's handy to have a better grip, and the larger, the more torque your hand can apply. All right, time to get these knobs off. Okay, all the nuts on the pots are loose. Should mention before I do anything else that I already made sure that all the caps were drained. There's no voltage in here waiting to zap me. And I'm removing the nuts and the little tooth washers that hold the board to the standoffs, and you'll see some of that now. The first two are off camera. I need to have the camera positioned so you guys can see what I'm doing, but also so that it's not in front of me and in my way. The next question, after I loosen the pots and get the toothed washers off, they use these black oxides, and I have found that these black oxides do not maintain a good ground connection over time. So I will be replacing them with the silvery ones, which seem to have a better long-term ground connection. And I'm seeing how sometimes you have to remove the wires, like the bias supply and these screen connections, to pull the board up, because the original just doesn't have enough slack. I think we're getting lucky on this one, because I don't want to stress the connections to the pots too much or strain any of the wire connections. On this one, I just have enough slack to change out these bias caps and to access this filter cap down here, so that's good. All right, here are the leads of the bias caps, and I've got this little window of wiring that I've got to get the soldering iron in without touching and burning any of these wires, because if I touch here or here or here, then we get burned wires, and it's ugly at the least, and you can actually cause shorts. So I've got a pretty good window here to get those out. And because these have angles to them, and this is a single-sided PCB with very thin traces, much like you'd find on a Fender reissue, it's not a very sturdy board. I don't want any mechanical stress, so I'm not going to yank them out from the top side. What I will do, and I'll show you as much as I can without changing the camera position throughout, is I will snip the leads on this side of the board. And then I'll probably burn my finger a little bit, but I won't burn anything on the board. I can take the iron and heat up that old solder and push that lead down from the other side. And then just kind of guide it out. Sometimes it'll fall out, sometimes I'll grab it with pliers. Most of the time, it'll just stick to the iron long enough for me to deposit it elsewhere. And this way, there's no stress on those solder pads. And I'm sure, a lot of techs watch this channel and comment on the videos. I'm sure many of them would be glad to share their experience where you get a 70s or 80s 2203 or 2204 in, and these traces on the board have just been screwed up royally by someone going in there and yanking on the leads from the other side, or having an iron too cold or an iron too hot, or not using the right solder. There are a lot of ways to do it wrong, and I'm sure there's a few more ways than this to do it right, but this is the way that works for me. And if I could find my fresh roll of desoldering braid. Here it is. Sorry, I've had so many things going at once. I get a little bit of clutter on the bench. I'm about to do one of my twice a year major cleanups and organizations. I think that's going to be this weekend. So I'll be able to find things and I'll have more real estate and life will be good. But you can use a desoldering tool for this, you know, a full desoldering station. You can use a solder sucker. I find that it's just as fast and puts no tension on the pads to use a high quality desoldering braid. Now I have used or tried many different brands of desoldering braid, and some of it is awful. Some of it you have to add flux to. It doesn't tell you that. Some of it just smears stuff out. Some of it gets stuck to the board. This is not an endorsement or an ad, but I found that the Tech Spray number 4 No Clean, which has flux in it, does a fantastic job. You can get that at Tube Depot. You can get it at Mouser. I'm pretty sure DigiKey's got it. I'm sure a quick Google search will tell you a lot of people wanting to sell it to you. But it really does a good job and removes quite a bit. And it's not very expensive. Paid $8 for a roll this size. And on things like this, where you have a fragile old trace on a PCB, or if we're working in those 63 JMI AC30s, where the tag boards themselves are very fragile, and the shock from a solder pult or the vibration from a full desoldering station can mess things up. I'd rather spend, if you have an amp worth $2,000 and up, spend $8 on desoldering braid just for that 1 amp is a no-brainer. Though usually I can use the same roll for multiple amps. So I've got some very clean pads, pretty much factory new. Let me find where I've got my new caps. They're in a Mouser box that just arrived. I'll pop them in. We'll solder those and we'll move on to the big filter cap stuff. All right, I've got some very nice brand new Vishay 10 microfarad 100 volts. I'll put those in place. And the first thing I will do is I will measure the spacing available on the board because I don't want them to have any strain on them. All right, that's 1 inch. So I just find the inch on this. And put my caliper back up. All right. I'm seeing this, and that's 1 inch, which means I don't need to even use this. These are fairly long, so I'll just do a gentle bend at the end of each one, and I want the value to be facing up. So the next guy will know what was changed and that it was changed to the correct value. And these just go right in to these holes now. They should have no real resistance, though the lead diameter is just pretty much at the maximum safe thickness for the existing holes. So there's a little bit of resistance, but it's not the kind of resistance where anything is getting damaged. So in situations like this, I will guide it from the other side. And, you know, why are you spending so long to change 2 little caps? You know, just caps, slap them in there. These are filters for the bias section. If something goes wrong on this, the amp can sound terrible. You could potentially lose a bias supply. All these are things that you don't want to do. So taking a little bit of time with these $2 caps can protect, in this case, a quad of EL34s. So 5 extra minutes spent with these $2 caps can save $200 on retubing, let alone any labor or, God forbid, a transformer, etc., etc. So I crimp them against the board with a mechanical lead. It's a little hard to do from the side like this. Anyway, I want them to be at a right angle and flush against the board. And then I will snip off the excess before I do the soldering, because it means I'm heating up less so I can work faster. And I'm less likely to shock a solder joint by cutting immediately after it's cooled. And I'll fish that lead that fell off out. I'm going to do the same to these. And I'm not applying a lot of pressure here. So the leads on the other side of the board at the body of the cap will not be stressed. But just some mechanical support so the very thin trace of copper on the other side of the board will not be bearing all the mass for these capacitors. Not that there's a huge amount of mass, but All right, so now I've got these caps, and they're physically in place, and they look neat, and they're secure to the board, and they've got gentle curves, so no real strain right where the lead leaves the body. And now I'm ready to resolder. Make sure the tip's clean. Now I'm working in this narrow window without touching any of the wires. So and I heat the component, and I heat the pad, and then I bring solder to that. And as I've mentioned in other videos, I'm sorry if my voice sounds weird when I bend over. It sounds weird too, saying that. As I've mentioned in other videos, it's hard to access this one. What was I going to say? On old components, if I'm doing an amp using a new old stock resistor, for example, or a new old stock film capacitor, I would never use a new old stock electrolytic. Though people will glad to sell them to you. That's just old junk. But if I use a new old stock resistor or new old stock film cap, I will usually clean the leads, usually with isopropyl alcohol, to get some old tarnish off the metal of the leads of those old components. And then I will often retin at least the area of that lead that's going to be soldered, just so that I can get a consistent, good, clean solder joint. But with these new Vichys, it was not necessary. I've got 4 very good solder joints with right angle mechanical support. Now it's time to turn our attention to the filter caps. All right, time to desolder this cap. And as I have mentioned earlier in this video, I had already made sure that there's no voltage here, so I won't get zapped. Now in this case, it's 2 red wires going to 2 sections. Each section is 50 microfarad. It doesn't matter which goes to which. In other places in the amp, that can matter a lot. I'm going to show kind of the principles and the whole thing on this filter cap. And I'm not going to show it on all the filter caps I'm changing. But there are a couple of considerations on the others that I'll mention as addendums, just a bit more info. But the process is pretty much the same on all of these. This amp has got a total of 6. So it would be a very long video if I did the exhaustive thing on all 6. So for this, I have to go a little bit left-handed because of where the tripod is and the angles that the wires attach. Let me show something that I don't need to do here because I've got some slack, but it's a good thing to teach people. You know, my primary goal of this channel is for guitarists to watch and learn more about amps, but I understand that there are a lot of techs who are seemingly learning from these videos as well. I've got a little bit of exposed lead here on this red wire. If I heat up this solder joint, that red insulation might melt. Sometimes when you have a little bit of exposed wire there, if you get in there with some hemostats, you can use an alligator clip on some stuff. It works as a heat sink, so the metal will heat up, but won't melt the insulation. Something else I need to show here is that old solder does not want to flow. And when you run into that, if you add a little bit of fresh solder, which has fresh flux in it, or if you use a flux pen or a very small amount of flux added to a joint, the old solder will flow just fine. And this is a little bit tricky to do left-handed, but the hemostat also makes a nice way to grab the wire. And like I said, it was not necessary in this case, because if a little bit of that insulation had melted, there's enough slack there that I could have stripped off the melted insulation. But by doing this, well, I pinched the insulation a little bit because there wasn't much slack showing off. You can see that the heat sink would take away any heat from melting that insulation. I'm actually going to strip off that little bit of crimped insulation. This was, again, more of a how to do something if you need to. It was not something I needed to do in this situation. So these wires are not mechanically supported from Marshall. They're just tucked in the holes in the old caps and soldered. So we'll do a bit better than that when we install the new ones. All right, now that I can pull these two red leads out, let me strip off that bit of crimped insulation. And before I do that, let me be smart and take that little blob of solder off at the end so that the insulation will strip. I'm going to strip both of these back a little bit compared to how they were, so that I can do a little bit of a hook. Oh, I'm dropping things too. I'm not using the lav mic. Let me plug that in. Sorry, it does sound a lot better when I use the lav mic. So that gives me a little bit of a break in the wire there. I'm going to make a judgment call since I've got enough slack on this. I'm going to snip the old ends off, and strip them both clean and tin them. And know that I have something solid and reliable down the line. Sorry about hitting the camera each time. Should probably learn to stop doing that. This is 22 gauge wire. Pretty sure I used the 20 gauge setting on the stripper just to make sure I didn't nick the wire, because it's really easy to do on this stuff. And I just twist it around on itself, like so. And then I will tin the wire. So when I bend it, when I attach it to the new cap, the strands won't separate. It'll behave like a solid wire as opposed to a few dozen little strands. Here's where it gets a little bit tricky as far as getting my mitts in. This is why it's really nice on this board that there's enough slack that it lifts up. Some of them you've got to disconnect some other wires to get this much slack. I'm not sure if you can see this very well. It's the same thing. I'm just heating up the old solder and pulling that out. All right, so that's part of the puzzle. I'm not sure if I'm going to show this because it's a total reset of everything. Yeah, I'll show it. What the hell? Okay, this is the clamp on this cap. And it's got this brass flathead screw. Whenever possible on Marshalls, I try never to use the brass flathead screw because it wants to strip, it wants to get mangled. So I'll just hold it in place with my finger and back out the nut on the other side whenever possible. And it gets complicated on the big bank of 4 caps we'll be getting to later because real estate gets really cramped. And I just want to get this loose enough that this cap will come out without the nut falling off. And sometimes I find it useful at this point to take a flathead screwdriver and kind of open that up. There we go. Now, before I put the new cap in place, I want to address the ground connection at the chassis. So let me put this back over the other way. All right. At the risk of sounding anal, I have found through experience that the connections to ground made to chassis here on Marshalls often get corrosion and they become very poor grounds. It's not always the case, and these actually look much better than in a lot of Marshalls, but it's always a good idea to triple check that. So I'm just going to loosen this nut from this side. I'm holding the screw on the other side with my finger because it doesn't take a lot to do this. And the nut fell out. I'll put it right here. And I've got this ground lug, this black oxide washer, and the brass nut. And you can see, let me see if I can really show it. There's a lot of junk there, a lot of corroded bits. And I want to have a very clean surface. Sometimes I need to burnish that old steel. In this case, I don't think we need to do that, but it will not hurt in the slightest to clean all these bits that touch each other with some alcohol, isopropyl alcohol. And you can buy the really pure 99% stuff if you want. Doesn't seem to make a huge difference versus the 91% stuff. We're not doing satellite grade equipment where the slightest imperfection can bring down a billion-dollar satellite or whatever. So the 91% stuff that they sell at Walgreens and CVS, etc., is usually fine for this kind of stuff. If you want to go get the pure stuff, be my guest. And I made a little bit of a clean spot in the chassis as well. I'm just going to take this bit that's already soaked in the paper towel. Can't really see all this, can you? I forgot to zoom out. Anyway, I'm just cleaning the individual bits in this alcohol-soaked bit of paper. Just gets yuck off. Someone's at the door. Someone else trying to get me to pay them to remove the tree that's down in our front yard. But the tree that is down in our front yard was originally in our neighbor's front yard, so I'm going to be happy to let them pay a tree service to deal with all that. I'm fully capable of going out there with a chainsaw myself, but it's occasionally not to have to do that. It's nice to not to have to do that. So I'll put this back exactly how it was. Now that I know all the mating surfaces are clean. Because the difference between a really good ground and a buzzy, hummy, bad ground can be like 3 to 10 ohms. Stuff that a lot of meters won't even tell you about. A lot of meters will just say, yeah, that's ground. You get a beep, a continuity beep, but if you really measure it, it's not perfect. So I want this to be really tight. Make sure this one's tight while I'm at it. Make sure this one's tight while I'm at it. And let me get the new cap in here. We'll tighten it up and then we'll solder it back together. Zoom back out to... All right, the new cap's in place, just below flush with the level of the chassis. As long as all 6 are at the same level, it doesn't really matter. You'll notice I have the ground connection lug on the other side. That also doesn't matter as long as there's a nice amount of slack, but the length is not too short. And just like I did on the others, I'm going to give myself some fresh wire to work with because this has got a little bit of destranding happening. And I will tin it and then we'll put it in place. Hitting the camera again. Consistency. That's what it's all about. Give that a twist. I want a little bit more than that. A lot of stuff, a lot of tedious stuff that happens in the background of making a big, loud, cool rock and roll amp. There's a lot of math too, but we'll do that off screen. Most of which has already been done for us, since we're not having to do any actual repairs on this circuit as far as I know. Just restoring original bits. All right. And I'm looking at that connection of the ground wire to that old solder lug, ground lug. And I think it needs a little bit of fresh solder there before I do anything else, just to be sure. Let's see if this does it well. If not, I'll take it apart and redo it. All right, there were just some exposed strands of the old wire there, and where the wire is exposed to the air and it's not soldered and the insulation was not there, it just gets a little bit brown. And I wanted to make sure that it was not getting corrosion, because that corrosion can actually wick inside a solder joint. It doesn't happen very often, but I've seen it both on Marshall grounds and on fenders. There'll be a corroded wire floating around inside a solder joint, particularly at tube sockets. So it can look just fine from the outside, but inside, beneath the shiny solder, nothing good is happening. All right, now got that little crimp there, because these slots on these F&T caps are open at the top. That can be lifted straight up by the next tech if necessary. So I'm not creating a problem, and I'm not doing a full wrap. I'm just doing half a wrap. I'm going to put a little mechanical pressure on it while the solder sits. And I know that I have a good connection at the ground lug. I've got a good connection here at the other ground lug, and then that whole connection to chassis is good and clean. And now I'll do these 2 reds. And the same process, just a little bit of a wrap. Boy, it's difficult to do with the tripod where it is. There we go. Got a better wrap on this one and this one than I did on that one, but that one's more than mechanically secure, so I'm not going to beat myself up over it. All right. That is a reliable, neat job. The other guy or gal 15, 20 years from now who follows me up on that will not be cussing me. Now, I have the amp open at this point. I want to go in here and make sure all these bolts that hold the output transformer and choke in place are nice and tight. Just do all the stuff that the board hides at once. Yeah, the choke hardware was really not tight in a couple spots. Not as big a deal on a Marshall as it is on a Fender. On a Fender, where everything hangs down, that weight over time can vibrate loose and deform the chassis and stuff. In a Marshall, it's typically less of a problem, but you still want things to be tight. Let's see, is this 11/32? Yeah, all right, so let's do the output transformer. Not too bad. All right, so that's all good. I'm gonna leave this board up in the air for a little bit because it makes it easier to access these two caps, which are the screen node in series. I guess you can't see it. This is the screen node, these two in series, and just being able to get it from this angle is nice. So I'll be doing this next. I think I'm gonna do this off screen unless I run into any real issues with it, which I doubt, but I'll point out something to keep in mind. All right, see these resistors here on the screen node? They're in parallel with each cap. Now, this is 250 microfarads here joined in parallel in series with another 250 microfarads in parallel. So that makes 100 microfarad, but they're in series. The end result is you're back at 50 microfarads. So why not just use one 50 microfarad here? Because that's what this whole capacitance is, what one of these individual sections on this cap is. Because this is a 500 volt cap in series with another 500 volt cap, and the total voltage capacity of this stage with these two in series is 1,000 volts. And in some Marshalls, the screen voltage can be over 500 volts. Never anywhere close to 1,000. But they just did this so that they wouldn't have to use a 600 volt cap, because 600 volt caps cost more than two 500 volt caps. So that's why that's there. And these resistors are 56K, and they're in parallel with each section of capacitance, which means that if there's, say, for easy math, if there's 500 volts coming in and these resistors aren't here, in theory, each cap would get half that, but in reality, this one may get 300 volts and this one gets 200 volts. By having well-matched resistors here across the whole thing, they're going to divide this neatly in two, which means that if there's 500 volts coming in, this cap gets 250, this cap gets 250. And that's really nice because in some circuits, or if a circuit is beginning to fail, if they don't have these balanced resistors, one cap can draw a lot of the voltage and a lot of the potential current, and that's why you have a premature failure. Now these caps for the reservoir first stage are also in parallel with themselves and then in series with each other, just like this. So you have another 50 microfarad stage, which is can handle 1,000 volts. This one does not have the resistor, and that's because this one has the HT center tap from the power transformer going to it, and having the center tap of the HT secondary tie into that point, given that this has a bridge rectifier, does the same thing as having these resistors. It forces the midway point of these caps to be exactly between the positive and negative voltage after rectification. And if you want to know more about that, the Valve Wizard has an excellent chapter or two on that subject. But that's why the screen in these Marshalls has the resistors and the reservoir or first filter stage does not. One little fun thing is that in order to get these caps out, the easiest thing to do was to remove the clamps for these caps, because this way now I can access the hardware that holds these in place. Before, the other tube clamps were in the way, but now I can get them there and get them out fairly easily, which is a nice thing. This one is being recalcitrant. Sir, I officially accuse you of being recalcitrant. There we go. And I'll be taking these ground connections out and cleaning them up the same way on the other thing. Let's do something for fun though. Let's get these old caps up here with their little bulges that are starting and see what the actual capacitance is across them. See how far off they are from where they started or where they purport to be. My old ESR meter died. I have yet to replace it, so all I can do here is measure actual capacitance. So even if all of these say 50, 50, 50, 50, exactly right as far as what we want them to say, that still doesn't mean that they're any damn good, because they could have terrible ESR. They are beginning to bulge. So this 50 microfarad stage measures 8.1 microfarad. This 50 microfarad stage measures 5.5. Wait, it's changing its mind. It's hard to make contact. We'll do it off screen here. I'm trying to be honest about this and show everything. Just trust me that I'm being honest. I just can't get the leads to stay on this. All right, so that one measures 58 microfarad. This one, I keep getting measurements like 4 nanofarad. I don't think that's right. Okay, 102 nanofarad. It's supposed to be 50 microfarad. 36 nanofarad. 36 nanofarad. Yeah, these caps are toast. They're all supposed to be 50 microfarad. For comparison, let's measure one of the new F&Ts that we're putting in place. Let's see. Where did I put them? I like to hide things from myself, you see. All right, here's one. And this one measures 52.17 microfarad and 51.52 microfarad. So don't say, oh, it's supposed to be 50 microfarad, it measures 51 or 52. There's a tolerance band here, minus 10% to plus 30%. And As long as it's within the expected range, that's fine. So there's a huge difference between 51 microfarad when it's supposed to be 50 and 700 nanofarad, like on the old black ones. So I think whoever last played this amp will be shocked next time that they hear it. But I'm going to take this ground hardware out, clean that, put these caps back in place, put the hardware for these caps in place, etc., and put it all together. Okay, I want to point out both a mea culpa and something which is actually, the same issue is why steel is better than brass. Notice I got a stainless steel nut here on this stainless steel screw. This is a ground connection, and I was when I was rebuilding it, trying to get really nice and tight, because that's the main ground for all the filtering in the amp, and that's really critical. And that old brass screw just sheared right off. Now I have the nut, and if the owner wants me to go get a brass flathead metric screw and put that back, I'll be glad to. I broke it. I bought it. I put in a stainless steel screw with a stainless steel nylock nut. Doesn't look period correct. It's infinitely a better long-term connection. It'd be very difficult to shear that off. And with a nylock, it's not going to vibrate loose ever. But it's the owner's call. But that's one of the reasons that when I build amps, I don't use brass hardware. I use stainless steel. I also replaced the wires going to the ground connections on these caps on both. The old one stuff was very short, it was very flimsy, and it was just tack soldered in place. And this black wire was just tack soldered to this solder joint. Got some 22 gauge bus wire. Nice little bend to it, so it won't be under strain, a little bit of flex. It's crimped here, and this wire is actually passing through this eyelet in this lug before it's soldered. So that's all good, and I'll build the rest of it in just a minute, but it's all back in place. I just wanted to point this out, that yes, we all make mistakes. The important thing is that I say, if you want me to fix this vintage, I can get a brass screw. This is actually a better solution than the original hardware, but it's the owner's call. So when I mess up, I'll put it out there too. There's a good reason for it, though. Brass hardware will break if you sneeze too hard. And trust me, I know about sneezing too hard. All right, looking good. All this stuff has been redone. I gotta say, the brass hardware on this amp was for shit. I've broken maybe 2 of those brass screws in 10 years. And now here I've done it on twice in one amp. So again, if the owner wants, I'll get the metric brass hardware. For right now, I've got the stainless in, which is better. The entire amp should have been built with stainless or some other harder metal than brass, but I'm sure someone's going to argue that brass nuts sound better. Hogwash, balderdash, harumph. But, if the owner wants the original kind of part, I'll source that out. If he just wants it to be rock solid and the best possible, it's got that now. The spacing between cap anodes is wider on the F&T than on the originals. So some of the wires that they had, where the old wire itself was joining them together in parallel, wasn't long enough. So each of these has been joined together with a little bit of bus wire, which is actually better. Gives mechanical crimp. There's one less thing to go wrong. So other than that, this is all back to where it started. Only, as it started at the factory, not as we started earlier today. So I'm going to put all the pots back in place and see what it sounds like after I get it biased. And we'll see if this amp needs anything else or whether it was just the caps. We shall see. Stay tuned. All right, so it's fired up, and there's no big hum, and there's no weird current draw. And the old 6550s, when I checked the bias on them, we're idling about 75% idle dissipation. And I don't know whether a previous tech had set the bias too hot. I think it's likely that as I changed the filter caps, all the voltages in the amp increased, and that's where we're at today. But if I bring up the master volume with the channel volume off, a lot of yucky sounds. Let me turn the master down, put it in standby, pull the phase inverter tube out of standby, bring the master back up, no sound. So all that yuck is in the preamp, and the owner expected to have new tubes put in. And I happen to have some that just arrived that we ordered for this amp. But that's going to be beyond the scope of this video. I wanted this video to be on the recap, and we're changing from 6550s to EL34s on this. So that all will be in the next video.